Okay, this is section 2.6, the last section in chapter 2. So we'll be working toward a test here after this section. This section is actually pretty short. It's about the intermediate value theorem. Okay, I'm going to give you the book definition and then I'll say it in terms that you can actually understand. It says if f of x is continuous for all values of x between a and b, and y is a value between f of a and f of b, then there is a value of x, which we will call c, in the open interval from a to b, for which f of c is equal to that y value. Okay, so in terms you can understand, got a function. We're going to pick an interval from a to b, and you can see that the graph is continuous all the way through there. So here is my corresponding y value for a, which we call f of a. Here's my corresponding y value for the b. Now what they're saying is, if I pick a y value between here, anywhere in here, the corresponding x value should be between the a and b that were established down here. So we're starting here, we should be able to find this c value. That's only going to happen if it's continuous on the interval from a to b. Alright. So, how hard are these problems? Not difficult at all. So, for f of x, which equals x squared minus 4, find a value of x, which we'll call c, between (3) and 5, where that f of c value comes out equal to 12. Okay, so we're going to look at the graph, see that it's continuous, and show that this intermediate value theorem holds true here. So we can find that value. Alright. So we've got x squared minus 4. Hopefully you know that's a parabola opening upward, slid down 4. So we'll go window, nope, zoom 6, and there it is. So the graph. Okay, I'm going to trace to 3. Looks like 3 is up here, 5 is up here. Trace 3. Yeah. So 3 to 5. I didn't quite hit the graph there, but we'll go over. So when the x is a 3, I should be coming up with 5 as the y value, and let's see why. Plugging the 3 in here, 3 squared is 9, 9 minus 4 is 5. Now when we plug the 5 in, let's see what that y value is. 5 squared is 25, 25 minus 4 is a 21. So up there's a 21 somewhere. So what this is saying is if I pick a number between these two, where 12 is between, my x value should come out between the 3 and the 5. Okay, my graph is a little bad here, but you get the idea. Our goal is to find this x value that makes the function equal 12. Well, that's just some simple algebra where we set the function. I want to know when it equals 12. Well, solving for x, if I add 4 to both sides, x squared equals 16. Take the square root. X could equal a positive or negative 4, because both of them squared give me 16. But if I look at the window I want the x value that's between 3 and 5. That's the positive 4. So, just not too difficult here. They're giving you a window on the x. You establish the two y values so that you can find the value, because this y value is between the two you found. So then you find the x that's between the interval given here. Try another one that you can't solve algebraically and see what we can do with that. Example 2. F of x equals x cubed minus 3x squared minus 6x plus 8. We're going to find a value of x, which we'll call c, between 0 and 1, for which f of c equals 1. Okay, let's first graph to make sure that we can find this value, so that this 1 comes out in between the two y values here. So graphing. X cubed minus 3x squared minus 6x plus 8. And we're only looking at the graph between 0 and 1. And get rid of some of the x. Maybe 4 to 4. Let's get the crossing a little close to the 1 there. So we're looking at the 0. If we put 0 in here, I can already tell that it's going to be 8. 0, 0, 0. This is up at 8. There it is right there, 8. And now if we put 1 in there, 1 minus 3 is negative 2. Negative 2 minus 6 is negative 8. 0. It does cross right here. 1. So we've established a y window of 0 to 8. The x window is 0 to 1. We're looking, where does the function equal 1? 1 is way down here. I want to know what this x value is, which we're calling c. So what we need to do is set this thing, x cubed minus 3x squared minus 6x plus 8 equal to 1. Well, try all you want with algebra. Good luck trying to solve that for x. Okay, so what we're going to do is use the calculator, and you might want to actually follow along with this, so you do it once before you get to class. We are going to have the calculator graph a horizontal line at 1, so we will make it graph this line, and then have it find this intersection. And when it gives us the intersection, it gives us the ordered pair. We're going to want the x value. with the y value 1. So, this horizontal line, all horizontal lines are y equals, and if y equals the number we're passing through y equals 1. So let's go to your graph, y equals, go down to the second one, y equals 1, graph that. There's the horizontal line. We'll have it find this intersection by going to calc. So second calc, we are looking for an intersection. That's number 5. Okay? Is this the first curve you want to use? And up at the top it says this y1, this x cubed one. Well, I've only got the 2 in there, so I just hit enter for yes. Is this the second curve you want to use? And see how it jumped to the y2 equals 1? Yes. Where's your guess on the intersection? See, there's 2 of them here. We're going to slide over to the 1. Help it out a little bit. Then hit enter when we're close to it. And it found the intersection. The y value is 1. The x value is about 0.889. So my C is about 0.889. Which is between the 0-1 window that was established by the intermediate value theorem. Okay, that ends chapter 2. But since this was so short, there is a skill you need to use in the next chapter, which we're going to go over right now. So we are going to do binomial expansion with Pascal's triangle. Okay, this you should have done in advanced algebra. I'm not positive. I know when Mrs. Deacon taught it, she was sure to hit it. I'm not sure if Mr. Drew did or not. But binomial expansion. When we have a binomial, obviously 2 terms, and we want to raise this to a power, first term, second term, third, fourth, fifth, sixth, we can use Pascal's triangle to help us do that quickly. Pascal's triangle starts with a 1 on the top. Then the next row is 2 1s. The row starts with a 1. The next term, it's like a pyramid you're building. You add the 2 numbers above it. So this would be 1 plus 1 gives me the 2 in the middle, ends with a 1. The next row starts with a 1. Here you add these 2 terms, you get a 3. The next 2 terms get added, that's a 3, and then we finish with a 1. Start with a 1, these 2 add to get a 4. These 2 add to get a 6. These 2 add to get a 4. And let's go one more. 1, 5, 10, 10, 5, 1. Okay, and the way you're going to use this Pascal's triangle is this first row is going to be your A plus B, not the first row, the actual second row. So we call this the 0 row here, with the 1 on top. And then this we call the first row. So this would be A plus B to the first power. And what that's telling you is the ratio is 1 to 1. You just throw away your parentheses. And we already know that. This is the second row. This would give us A plus B squared. This is basically our FOILing row. This next row is A plus B cubed. We would use this row, the 1, 3, 3, 1. We're going to use this one a lot. This is going to give us our A plus B to the 4th, and then our A plus B to the 5th. Okay, so how does this work? Let's say we're going to do 2 of these. Expand, let's say we had, what do I have here? H plus 2x to the 4th power.